All right, here we go. This is number 31 from the third quarter study guide. This is where we left off, and it says, the graph of g of x is shown below. The graph of g of x can be obtained by transforming the parent function of f of x equals cube root of x. What is g of x? So they're telling us that this is g of x, but it comes from the parent function, what? F of x cube root of x. So they want us to figure out what this function is. So first things first, we need to write our general transformation function. What does it look like? G of x equals a times cube root of, what else? Who remembers what goes inside? 1 over b, very good, parentheses, x minus what? H, that is correct, close parentheses, and outside the radical, what do we write? Plus k, that is correct. You're like, I remember this with the q, I know, right? And so basically, what information do we need? We need h and k. So looking at this function, h and k, the vertex is where it changes direction. So it's coming like this, and all of a sudden it changes direction right here. Is that correct? So place your point there. And that's going to be our h and k. So what is this point, guys? Negative 2 what? Negative 4. So that is negative 2, negative 4. So basically here, we're going to substitute what? Negative 2 and negative 4. Okay, we got that. So now all we need to figure out is what? A and B, which means we need to pick another point. And remember, I try to pick points that are on the right side of the vertex. So you see another point where this function passes through. Yeah, right here. Place your point right there. And what is that point? Negative 1, negative 3. So I'm going to write negative 1, negative 3. That's this point. So what I mean is that, let me zoom in. Notice that the graph is passing right at the point that this and this intersect about right there. I can pick a point here, but then I'm going to be working with decimals. So we need something that's like a whole number or an integer. So I'm going to pick this point, and that's why this becomes negative 1, negative 3. So since we need to figure out A and B, that means I need to write what? B plus H, comma, and A plus K. Does that sound familiar? Yeah, right? We've been doing this with all the other functions. So I'm going to figure out first B. That means I'm going to write B plus H equals negative 1. However, what is H, guys? Negative 2. So I substitute H in there. So that is, let me try like this. I'm going to substitute H in here. So this is negative 2. I bring everything else down. The B equals negative 1. And I'm going to solve for B. Plus 2 plus 2. B equals 1. And that goes right there. All right. So now I just need to figure out what? A. So that means I'm going to take this and I'm going to write A plus K equals negative 3. But instead of K, what am I going to substitute in there, guys? Negative 4. Goes right there. Negative 4. So I bring everything else down. A equals and negative 3. So therefore, what do I do here? Plus 4 plus 4. A equals 1. That goes right there. Okay, so now let's substitute values. So my function g of x for this function, g of x equals Do I need to write the 1 for A? No, it's an invisible 1, so I write cubed root of. Do I need to write the 1 for B? Let's see, what is 1 over 1? 1, so do I need to write 1? No, so that leaves me with what? X. And what is negative times a negative? Plus 2, and what goes outside? Minus 4. This is my g of x. Am I done? Let's see. The graph is shown, and the graph g of x can be obtained by transforming the parent function. What is g of x? That's it. They don't ask us to describe the transformation. But let me ask you a question. Look up. Look at this. What is the transformation to that function? What is it going to do to the original one? Tell your neighbor. What does it do to the original one? 2 to the left and 4 steps down. Let's see if it's true. If it was starting over here, let's see. 1, 2, and 1, 2, 3, 4. That is correct. Let's go. Piece of cake, yeah? All right. Let's go to number 32. Oh, yeah. Let's go. Oh, thank you, too. Your favorites, right? Let's see. All right, for this one, check this out. I'm going to have you, let's see. We're going to switch it. Yeah, let's switch it. Let's change the 5, and we're going to use better. You have your study guides with you, yes? F of x, let's write 27x cubed. All right? All right, so here goes the process. What is the first step, everyone? Changing it equal to y. So this becomes y equals 27x cubed. Let me zoom in. All right. Next, we need to leave the x cubed by itself. So what do? Divide by 27, divide by 27. I end up with y over 27 equals x cubed. How do I cancel this cubed? Cube root. Cube root. So this cancels this. We're left with x equals. All right. Can we rewrite this? Yes. This is what? Cube root of y over, what is cube root of 27? 3. That is correct, because 3 times 3 times 3 is 27. Next, we need to exchange the variables. Yes, this one goes over here, this one goes over here. So my new function is cube root of x over 3 equals y. And can we leave it equal to y? No, it needs to be in function notation. So f inverse of x equals cube root of x over 3. This is my inverse. Yes? All right. Did it say to check? Yeah, let's go. Our favorite. So, when you get to that point, check this out. This is what I want you to do. On the side, over here, you're going to write first f of x equals 27x cubed. And next to that, write the inverse, but draw a line down so like that you don't get confused as to where you're working. So then I want you to write f inverse of x equals cube root of x over 3. Now, why do I want them side by side? Because you're going to see right now. So check this out. So the next step here is writing f parentheses, don't write the x, 27 parentheses, don't write the x, and the power. Why do I do that? Because now, check this out, I need to write this in here and this in there. Does that make sense? So therefore, and by the way, hold on, before I get started with that, I'm going to write the next step for this one also, f inverse of parentheses equals cube root of parentheses over 3. Why did I do that? Because when I check this one, I need to input this in here. So check this out. I'm going to go with the inverse. So I write f inverse of x. Did everybody notice that I input this right here? So what goes right there? This. Cube root of x over 3. Yes? All right, so let's finish this one, checking this one, and then we're going to check the other. So let's see. Again, I'm going to write f inverse of x equals to 27 times, now let's see, we have an exponent outside, that means I can distribute, is that correct? So I'm going to do that in black so you guys can see the difference. So I'm going to distribute this in here and to the denominator also. So if I multiply this power to the cube root, what happens to the cube root? It cancels this, so I'm left with x in the numerator. Does everybody see that? If I distribute the cube to the denominator, what is 3 cubed? 3 to the third power is 27. Everybody see that? This is an exponent. It's not a number. It's an exponent. It's not a whole number. It's an exponent. So 3 to the third power is 27. Cube root of x is only x because the cube cancels it. All right. Everybody there so far? Yes, Mr. Q. So f inverse of x equals to, so let's see, I need to do the next step. I'm going to write the 27 over 1, so if I multiply, what do I get? 27x over 27. And my last step, f inverse of x equals, what is 27 over 27? A giant 1, is that correct? Here's a giant 1. So I'm left with x. I like these, yeah? These are good, yeah. So let's do the check for this one. What goes in here instead of x? F of x, right? F of x. And in here, instead of x, we write the function, which is what? 27x cubed. All right. Next, f inverse of f of x equals, let's see, you can barely tell what this is, sorry. This was x to the third power. All right, so check this out. This is inside of the radical, yes? So what is cube root of 27? 3. And what is x cubed to the third? X, because we divide this by this, right? So it's x, or x to the first. What stays in the denominator? 3. So my next step, f of x equals, what is 3 over 3? 1, so we're left with x. And we're done with our check. All right, these are pretty good, right? All right, so let's graph this. So to graph it, I'm gonna, my inverse is here. I'm gonna write my, my f of x right here equals 27x cubed. So to graph that, I'm gonna make a table, x, f of x. All right, So who remembers that the only graphs that were perfectly symmetrical with their inverses, they were what? The cubic and the cube roots. Remember those? Yes, Mr. Q, my favorite. So that means I'm going to get at least 1 point from the negative, the 0, and 1 point from the positive. So I'm going to start with negative 1, 0, and 1. So let's see. Negative 1. What is negative 1 cubed? Negative 1 times 27. Negative 27. Okay. 0 cubed. 0 times 27. 0. 1 cubed. 1 times 27. 27. Okay. So if we were to graph this, we got 0, 0. Negative 1 times 27, which is somewhere over here. And 1 times 27, which is over here, it's going to look something like this. Okay, I'm done with the function. Now I'm going to do the inverse. F inverse of x equals cube root of x over 3. And again, I'm going to use x, f inverse of x. And what values am I going to use again? Negative 1, 0, and 1. All right, so I'm going to substitute negative 1 in here. Wait a minute. Can we get a negative? Yeah. Cube root, what number times itself gives us negative 1 3 times? Negative 1 over 3. Negative 1 over 3. Okay. About 0? 0. About 1? 1 over 3. Okay. So negative 1, negative 1/3 is right there. 0, 0. 1 and 1/3. So that one looks like that. I like these. They look like the Power Rangers, right? No? Do I zoom in? Do you guys catch that? Negative 1, negative 1/3. 0, 0. 1 and 1/3. And there it is. Does it look like it's inverse? Let's see. It does, right? Looks like it's going like this. Does anybody break down some here? No? Huh? Perla? Nice. Let's go to number number 33. You got this? Yes? All right. 33? All right. So for this one, step 1, we need to iso the radicals. They need to be each one on its own side. So, line down the equal sign. Which radical can I send to the other side? M plus 6. So that means I need to add square root of m plus 6 to each side. Add square root of m plus 6. That leaves me with square root of 3m minus 8 equals square root of m plus 6. At that point, how do we cancel these radicals? Square it. So we square this side and square that side. This cancels this. We're left with 3m minus 8 equals m plus 6. Some of you are like, oh, I can't believe it's that easy. I know, right? What do we do then? Get all variables to one side. Where do I start? Minus m. We're left with 2m minus 8 equals 6. And then plus 8 plus 8. 2m equals 14. And lastly, divide by 2. M equals 7. So what's the major idea about these? That you need to get one radical on each side. They need to be by themselves. Okay? Kind of like you and your brother or your sister, you can't like usually be together all the time. Oh yes, we can be together all the time. All right. Let's go to 30. Any questions for this one? We good? Yeah. 34. Let me zoom into this one. This one is solve the equation, parentheses, negative 3x plus 18 to the 1/2 power equals x. Let's see. There's two ways of doing this one, but let me just start with the simple way, or both of them are simple. What am I talking about? What do we know about 1/2 power? What does that become? A square root. That is correct. 1/2 power is a square root, so I'm left with negative 3x plus 18, and all that equal to x. Question, how do I get rid of this square root to get started? We need to square, and whatever I do to one side, I do to the other side. We're left with negative 3x plus 18 equals to x squared. And now I need to solve the quadratic equation. How do I solve the quadratic equation? By setting it equal to 0. Now, instead of bringing this one over here and having a negative leading coefficient, I'm going to get these and bring them over here. So what do? Plus 3x and minus 18. Plus 3x minus 18. So now we have 0 equals x squared plus 3x minus 18. Do we know what to do from there? Yeah. Negative 18 is our product. 3 is our sum. What are the factors of negative 18 that add up to positive 3? 6, negative 3? 6 and negative 3, let's see. 6 times negative 3, negative 18. 6 plus negative 3, yep. So instead of doing the grouping, let's go a little bit faster and do our function, our factors from there. So what is my first factor? X plus 6. What is my second factor? X minus 3. Man, these are so easy, right? Pearl be nice. So what do we do from there? Set them equal to 0. X plus 6 equal to 0. X minus 3 equal to 0. So then we just solve. So this is minus 6 minus 6. X equals negative 6. Bless you. Plus 3 plus 3. X equals 3. These are my solutions. Piece of cake, yeah? It's like running your 2 miles every day or something like that. Right? How are we doing, yeah? Is it coming back? Yeah, right? Bless you. All right, let's go to number 35, yeah? 35. Oh, these are tweezing. Says, simplify the expression. Assume that all variables are positive. We have 4th root of 256 z to the 16th. Let me zoom in a little bit more. So first thing that we need to do is rewrite it, yes? So let's write the number by itself in the radical times the variable by itself in the radical. So what do I have? 4th root of 256 times 4th root of z to the 16th. I remember when we covered these, I gave you more variables and we separated it all, and then at the end we brought them together. You guys remember that? So let's simplify each one at a time, and then we'll bring them together at the end. So question. This is to the 4th root. That means what number times itself 4 times itself 4 times gives me 256. Let's see. Is it 1? 1 times 1 times 1 times 1? No. 2 times 2, 4 times 4, 16? No. 3 times 3, 9 times 9, that's 81. No. 4 times 4, 16 times 16, 256. That is correct. So this is 4. Yes? All right. Now, who remembers these? Whenever we have a variable with an exponent and an index, tell your neighbor what to do here. What do we do here? Yeah, you check to see if we can divide the exponent by the index if it's of the same multiple. So let's see. 16 divided by 4. 4. So that means I'm left with z to the 4. You can write the multiplication sign here or not, but this is the answer. Yeah, because it's the multiple of that, yeah. If it didn't multiply, you guys remember when I did something like this, if I was to give you something like this, z to the 17, then you would rewrite this as z to the 16 times z to the first. Yeah? This will simplify, but not that one, so. All right. That was number 35. Let's go to number 36. 36. Let me zoom out. It says, write the expression 8 to the 5/3 power in the radical form and simplify. Round to the nearest whole number if necessary. So, I'm going to zoom in. So I'm going to write that here again, just so that I have it here. 8 to the 5/3. Well, first of all, we need a fraction where the numerator is what? 1. So I'm going to rewrite this as 8 to the 1/3 power. However, the power also needs to be multiplied times what? To the 5th power. This is this. But why do we need it to the to the power of 1 over whatever number? Because this becomes a radical. Circle this one in, circle this one in red so that we remember. This becomes a radical. So that means radical 8, and the denominators are index. Oh my goodness. Our index. All right, so where do I put the 5, Mr. Q? Well, outside. We need to raise that at the end to the 5th power. All right, so question. What number times itself, how many times? It says here 3 times, give us 8. 2. 2 to the what? 5th. So what is 2 to the 5th? That's 2 times 2 times 2 times 2 times 2, which is, what is it, 32? 32. Oh, I like these. These are pretty good. How are we doing? Yeah? Swell. Did you say swell? Swell. Okay. All right, let's go to number 7. Number 37, I'm sorry. It says, number 37, it says, write the recursive and explicit rules for the nth term of a sequence. Recursive and explicit. Before we get started with the last two, let's see. We need recursive and explicit. Now, those of you that have been coming to tutoring with me, we did a memory practice for these. Remember these? Arithmetic, geometric. And right now we're going to assume, like the sequence that I gave you, that n is greater than or equal to 1. All right. So let's see. Recursive. Who remembers how both of them start? F of n equals to f of n minus 1. Both of them start the same. F of n equals f of n minus 1. However, this is arithmetic, so what do we do at the end? Plus b, and this one times r. That is correct. That's the only difference from one to the other. You guys remember these, yes? Your favorite? Good. All right. Let's go to explicit. F of n equals f of 1 plus b times n. Man, you guys are reminding me in kindergarten. There you go. That is correct. And remember that this one starts the same. F of n equals f of 1, but it's times r. Is that correct? However, this one doesn't have a multiplication. It has a power of what? N minus 1. That is correct. Let's go. And what did we say was the difference between the recursive and the explicit? That the recursive, if they ask us that we need to find the 100th term, that means that we need to find the 99th term. Is that correct? And if I don't have the 99th, that means I need to find what? The 98. And if I don't have the 98, the 97, and so on and so forth. So which of these two would we use if they wanted us to find the 1000th term? The explicit. That is correct. All right, now let's go to the problem at hand. Write the recursive and explicit rules for the nth terms of the sequence. So they give us this sequence. So check this out. When you get to these, this is what I want you to do. You're going to make a table first. So, do you have space above it over here, or shall we do it right here? Let's do it right here. We got n, f of n. We got -8. That's my first. Yes? Then 9, which is our second. And then third, which is 26. And then fourth, which is our 43rd. And then fifth, which is our 60. Now with that, we can actually find the pattern. Look at it. What's happening from here to here, from here to here, here. Plus 17. That is correct. If we're adding or subtracting, what kind of sequence is this? Arithmetic. That means this is our D. Now we know which two functions to write. Is that correct? Let's write our recursive first. Recursive. And then over here we're going to write our explicit. So recursive is f of n equals f of n minus 1 plus b. But that's just the general form. Now we need to write it so that it's specific for this. So what do I write? F of n equals f of n minus 1. However, at the end what? Plus 17. So this is our recursive for that sequence. Let's write our explicit. F of n equals f of 1, what else? Plus d times n minus 1. Next, f of n equals, at this point we can input stuff, is that correct? What's our first term? What is f of 1? -8, so I'm going to substitute that in here, -8, plus, what is d? Plus 17 times n minus 1. And this is our explicit rule for this sequence. Negative, it's our f of 1? Yeah, our first term, yeah. All right. Yeah, so if you didn't see, f of 1 is our first term, which is this one. and that goes in here. All right, so now that we have that, question, what term do they want us to find? 100. Yeah. So do we use the recursive? Why not? Because we need the 99th term. Do we have the 99th term here? That means we need to find the 97th. Do we have it there? No. That means I need to find all the ones before 100. So this will be crazy unless you guys want to do the workshop. So that means we need to use which one? The explicit. So what do I write? I write f of, instead of n, what do they want me to find? 100 equals negative 8 plus 17 times what? 100 minus 1. F of 100 equals negative 8 plus 17 times 99. F of 100 equals negative 8 plus, I'll wait for you to do that computation. Yeah. What is it? And what? 83? Damn, Diego. Let's go. F100 equals 1683 minus 8, that's 1675. And we're done. Too easy. Right? No. Too easy. That's what it is. So let's see the process. Step 1, we make a table. Step 2, we find our pattern. Step 3, that tells us what kind of sequence we have, and we write our recursive and explicit. Substitute the D into both, and for the explicit, the first term. And then from there, go to whatever term they're asking us to find. All right, next, let's go to number 38. It says, write the recursive and explicit rules for the nth terms of the sequence and find the 20th term in the sequence. All right, tell you never the very first thing you're going to do with those numbers. Very good. Make a table. Oh my goodness. And f of n. What's our first term? Negative 2. Our second term, negative 6. Our third term, negative 18. Our fourth term, negative 54. Our fifth term, negative 162. All right. That's the first thing we do. What is the second thing we do? Check to see if there's a pattern. Is that correct? All right, let's see. What's happening from here to here, from here to here, and here, and here, and here, and here? Times 3. So if we're multiplying, what is this, everyone? What letter? R. I wanted you guys to go like pirates. R. Have me be nice. All right, now that we have R, what does that tell us? What kind of sequence is this? Geometric. So we need to write our recursive, and explicit. However, it's for a geometric. So let's see. What's our recursive? F of n equals f of n minus 1 close times r. Yes? So specifically for this sequence, it's f of n equals f of n minus 1, and at the end, times 3. And this is the sequence recursive rule for our sequence given right there, specifically. All right, let's write our explicit rule. F of n equals f of 1, that doesn't change, and then times r, but this one, instead of having the times n minus 1, it's to the power of n minus 1. Yes? All right. So let's write it specifically for this one. So it's f of n equals, what goes here for the f of 1? Tell your neighbor, please. -2, that is correct. Times, what? Times 3. And then n minus 1. And this is my rule, my explicit rule specifically for this sequence. Question, they want us to find the 20th term. Which one do we use, the recursive? The explicit, that is correct, because this one takes us straight to the term. So I write what? F of what? F of 20 equals -2 times 3 to the 20th minus 1. Let's do one more step. F of 20th equals -2 times 3 to the what? 19. And this is as much as I want from you, since you're not using a calculator, and I don't want you to use a calculator. The calculator is just computation. I just want to make sure that you understand the process and which one to use. All right? Y'all watching the video. Any questions, guys? We good? What is it? Why is it? Oh, because n is the term that they want us to find. What term do they want us to find? The 20th. So instead of n, we substitute 20 and 20. Yeah? And we'll stop right there. I'll upload this video. This will be part 4 of the 3rd quarter study guide. Enjoy. A good one. See you guys later. Bye.